In this video, we go over what complex numbers are and how they relate to imaginary numbers and how to multiply, how to simplify them, and what I represents. All right, so a complex number has a real component and it has an imaginary component. So complex numbers have a real component and an imaginary component, and it looks like this: a plus bi. So a is the real part, b is the imaginary part. I represents the imaginary term here. So there we go. I equals the square root of -1. Okay, now we all know square root of 9 equals 3, because the square root of 9 is really asking what number multiplied by itself equals 9, and that answer is 3, because 3 multiplied by itself is 9. It gets tricky though if you ask, what is the square root of -9? A lot of people would think it's -3, but that's not it, because -3 multiplied by itself is actually +9. -3 times -3 is +9. There's no real number that multiplies by itself to get -9. And that's where the imaginary numbers come in. So if I represents the square root of -1, I can rewrite this as the square root of -1 times the square root of 9. And now I can replace the square root of -1 with I. Square root of 9 is 3. So this whole thing equals 3i now. So the imaginary number would be 3i. If I was to write the entire complex term, I would need a real part and an imaginary part. In this case, the real part doesn't exist. So it would be 0 plus 3i if I needed all of it. Okay, so that's just the basics. Let's come up with another radical that we can simplify in terms of imaginary numbers. Let's say we just have the square root of -20. Okay, if I break this down, square root of -20 would be square root of -1 times 4 times 5, if I were to break it all down. And then 4 breaks down into 2 times 2, so really that's 2 squared. And I'm able to take a 2 out. Okay, so I've got 2 on the outside times the square root of -1 times the square root of 5. I can break up that house into 2 different radicals. Square root of -1 is I, so I have 2i times the square root of 5. Okay, that's another example of simplifying something down so it's got the imaginary numbers in it. If you're adding and subtracting imaginary numbers, let's say we've got a complex number, let's do 3 plus 5i, and we're adding to that. In fact, we'll put it in parentheses just to keep it together. And let's say we're adding another complex number, 5 minus 7i. Okay. When you add complex numbers together, the real parts would add together or subtract together, and the imaginary parts would get together. It's a lot like my friends, personally. My real friends can get together, my imaginary friends can get together, but my real friends and imaginary friends just can't. Lowers my street cred, and so that just can't happen. So real things can get together. 3 plus 5, there's nothing outside the parentheses, so that's just 8, plus 5i minus 7i actually is a negative, so I'm going to change that to a minus 2i. You always put the real number at the front, the imaginary one at the back. You'll never see the imaginary friends at the front. If you see this, you want to rearrange it. You always want to keep your real friends before the imaginary friends. Okay? So now let's go through an example where we're multiplying to show what happens when you're multiplying numbers with imaginaries in them. I've got this 3 being multiplied by this complex number. So if I distribute here, 3 times 2 is 6, plus 3 times 5i. The 3 and the 5 can multiply together and get 15, and then I have an I stuck at the end. So when I multiply the 3 in, 3 times 2 gives me the 6. 3 times 5i is 15i, and that's okay. But where it gets tricky is what happens if I have an I that multiplies in? All right, so let's say I've got I times parentheses 3 plus 5i, something like that. Okay, I distribute in. I times 3 is 3i plus I times 5i is 5i squared. Now, what is I squared? If I is the square root of -1, then what is I squared? If I were to square both sides here, I squared would equal the square root of -1 squared. And then a square root and a square cancel each other, so they cancel. So I squared equals -1. If you ever see an I squared, you just replace it with a -1. So if I replace this with -1, I get 3i plus 5 times -1, which is -5. So 3i minus 5. Is that in the right order? No, you can't have an imaginary friend before the real one. So we switch the order. The 5 is negative, so I get -5. 3i is positive, so that's plus 3i, and now it's in the right order. Okay, so anytime you have I squared, replace it with -1. I is the square root of -1. I squared equals -1. There's going to be times where I get an I to the third power. Well, that ends up being I squared times I. Well, that's -1 times the square root of -1. That's going to show up. And then the other one you're going to see is I to the fourth. I to the fourth is really I squared times I squared. So -1 times -1. -1 times -1 is +1. So if you ever see I to the fourth, this just equals +1. So just to write this clean, I have I equals the square root of -1. I squared equals -1. I to the third power equals negative square root of -1. That's just that times that. I to the fourth equals I squared times I squared, so +1. And then when I go to I to the fifth, it starts all over again. I to the fifth is really I to the fourth, or 1, times the square root of -1. I to the sixth is -1. I to the seventh, I to the eighth, I to the 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th. It just is a cycle that keeps going over and over. So if I have I to the 22nd power, because every time I get to an I to the fourth, it cycles over again, I want to find the closest I to the fourth multiple that I can. Well, 20 is a multiple of 4, so I to the 22nd is really I to the 20th times I to the 2nd. I to the 20th is just 1, it goes away. So really this right here is going to be I to the 2nd, which is -1. Kind of fancy, huh? Let's do another one. Give me a random number. I to the 75th power. Good one. I like it. So we want the closest multiple of 4 I can think of. So 4 goes into this how many times? Well, let's see. 8 goes into 72. So if 8 goes into 72, that means 4 does also. So this is going to be I to the 72 times I to the third power. That'd be 3 of them left over. So this right here equals 1 times I to the third, which is negative square root of -1. So I know that I to the 75th power equals -1 times the square root of -1. Boom. So that multiple of 4 really helps simplify this stuff pretty quick. Just for fun, one last little quick example. Let's say I have 5i to the 7th power multiplied by 6 plus 9i to the 4th. 14th, make it 14th. Okay, I can start from here. Let's just say we had to multiply it straight in. I'm not even reducing anything yet. So I have 5i to the 7th times 6. 5 times 6 is 30. I to the 7th plus, now I do 5 times 9 is 45. How many i's do I have? I to the 7th times I to the 14th. If I listed them all out, there'd be 21 of them. All right, so if I simplify it from here, this would be 30 I to the 4th, I to the 3rd. The I to the 4th goes away, it's just 1. And then I to the 3rd is negative square root of negative 1, or I. So let's just change this to a negative I. So this would be negative 30 I. Okay, that negative gets attached to the 30, and then square root of negative 1 is just I. Plus, okay, 45. Now, let's figure out what this is. 45i to the 21st. Well, 20 is a multiple of 4, so that would just go to 1 and go away. So I still have another I on there. Okay, well, now I have like terms. I have negative 30 i's plus 45 i's. So total, that would be 15i. And there we go. So there's no real component to this, just an imaginary component. And we go from there. So hopefully that made some sense. Just a quick little explanation on complex numbers and imaginary numbers, how to multiply them and how to simplify when you have something more than I to the 4th. Okay? Let me know if you have any questions. If there's anything I can do to help you, let me know. Leave a comment down in the comment section. I'll get back to you as quick as I can. Give this channel a subscribe and a like, and we'll see you soon. Have a good day.